Example 8, we're graphing another function. Maybe this one looks familiar because it was one that we did back in example 4. Example 4c was the same thing, and if you look, we did a vertical asymptote was x equal 1, and then it had an oblique asymptote. So notice we had to do synthetic division or long division or something to find that oblique asymptote. So we have step 1, find the vertical asymptote. According to example 4, at x equals 1. And because the degree of the top was equal to the degree of the bottom plus 1, we had an oblique or diagonal asymptote at y equals x plus 2. Okay, so let's go ahead and draw that in. We have a vertical asymptote at x equals 1, and we have an oblique asymptote at y equals x plus 2. So remember how to do that. You start at 2, and you go up 1, right 1, up 1, and right 1, up 1, and right 1. And I would recommend you do a lot of points, or try to follow the pattern. If you do it freehand, it's pretty tough to do, so you have to be really, really careful. Y equals x plus 2 looks like that. Now step 3, we're going to plug in 0. Plug 0 into the function, you're going to get 0. So we've got that point right there. Step 4, we want the x-intercepts. So remember, that's if the top equals 0. If we had the top equals 0, there's a GCF. I could take out an x. I would have x plus 1. X times x plus 1 equals 0. Only when x is 0 or x equals negative 1. So we've already got the 0 graphed there, but we've also got a negative 1. Okay. Step 5, we want to know if this thing crosses. Does our graph cross the oblique asymptote? So take your function, x squared plus x over x minus 1, and set it equal to the oblique asymptote right there, x plus 2. So we're going to have to cross multiply, and that means that we're going to have to take that x plus 2 over there times x minus 1. It's a FOIL problem. So x squared plus x equals, really that's a question, I guess. Is that true? Or where is that true? So foiling out the right side, we'd have x squared minus x plus 2x minus 2. And combining like terms on the right, x squared plus x minus 2. So if you notice, some nice stuff happens because some things start canceling out. The x squareds would cancel, but the x's would also cancel, leaving me with 0 equals negative 2. That's false, which means that our curve is not going to cross that oblique asymptote. It does not cross. So after that, I'm going to need to make a table or something to just fill in some extra points. So step 6, make a table. Now remember your vertical asymptote. Your vertical asymptote is at x equals 1, so that's the number that you can't plug in. Don't plug in a 1, but we could plug in, I don't know, some other stuff, negative 3, negative 2, negative 1, and 0. And so let's go back to our calculator again and see I've got it plugged in. The graph looks kind of strange with that oblique asymptote, but go to the table. And if I plugged in negative 3, I've got negative 1.5. Negative 2 is negative 0.6 repeating. Plug in negative 1, you get 0. We already have that point anyway. Plug in 0, we get 0. We already had those points. So negative 3, comma, negative 1.5. 3, negative 1.5 is right there. Negative 2, comma, negative 0.6 repeating is going to be about right there. And so, look at what it looks like. Okay, remember it's going to approach your asymptotes, so it's going to look something like this. Hit those dots, and curve down. Okay, so what happens on the other side of the asymptote, like we want to plug in maybe 2, 3, and 4. So go back to the table, plug in 2, you get 6, plug in 3, you get 6, and 4 is 6.6 repeating. 6, 6, 6.6 repeating. So 2 comma 6, 1, 2, 3, 4, 5, 6, 3 comma 6, and 4, 6.6 repeating is right there. So we've got to approach the asymptote, hit the curve, and go up through. Let's try to smooth that out a little bit. Example 9, graph this function. Step 1, we want to find the vertical asymptotes, and that's just going to be where the bottom equals 0. Okay, but you got to be careful, because if something cancels out, then that's not a vertical asymptote, it's a hole, and you always have to be careful, and you always have to watch out for that. So what you're going to need to do is factor on the top. The top, you need two numbers that multiply to -6 and add up to -1. The top is going to be x minus 3 times x plus 2. So if you notice, the x minus 3 actually cancels out. And so we're not going to have a vertical asymptote, we're going to have a hole. And so this is the first one of these that we've seen. It's a hole, not a vertical asymptote. So your function actually reduces down to something that looks like x plus 2, and you should know what that looks like. If I draw the graph of it, it just looks like a line. It's the line y equals x plus 2. Okay, now there's more to it because it's got a hole in it. So let's check out what else it would have. Okay, so there's a hole at x equals 3. Step 2, we would normally do a horizontal asymptote. But if you notice, the degree of the top is 2, and the degree of the bottom is 1. The degree of the top is the degree of the bottom plus 1. That's where we don't have a horizontal asymptote, we have an oblique asymptote. So if you do the long division, or you do the division here, you've got 1x squared, -1x, minus 6, and you're going to do long division on the 3. So add down as 1, multiply as 3, add down as 2, multiply as 6, add down as 0. We've got a remainder 0, which I don't even want anyway. I want the constant and I want the x term. But that's just x plus 2. That's x plus 2. And that's exactly what the function was anyway. So it's kind of weird. Our oblique asymptote seems to be the exact same as the actual graph of the line. Okay, so that's kind of weird. So step 3 says plug in 0. Okay, so we can do that. We plug in 0. F of 0 equals -6 over -3 is going to be 2. Okay, let's go ahead and graph this. Okay, so well, I guess we got 0, 2. We get this point. Okay, of course we've got that point. It's the line x plus 2. But let's continue on with our steps. The x-intercepts, okay, the x-intercepts are going, well, it's just going to be at -2. You look at what's going to make the numerator equal 0. Well, you can't have, you want to say the x-intercepts are +3 and -2 because that's what's going to make the top equal 0, but you're not allowed to have x equal 3. That's not going to be part of the domain because that's going to make a 0 on the bottom. So you're only going to have an x-intercept at -2. Step 5 says, does this thing cross the asymptote? Well, if you look at it, if you set the function x squared minus x minus 6 over x minus 3 equal to the oblique asymptote there, x plus 2, well, once you factor and cancel, Once you factor this into x minus 3 times x, times x plus 2, once the x minus 3's cancel out, you've got x plus 2 equals x plus 2, and that's always true. Okay, it's always true. And so what that means is your line crosses the oblique asymptote everywhere. And that makes sense because the equation x plus 6, or the graph of x plus 2 rather, is the exact same thing as the oblique asymptote. So of course it's just going to cross right there. So we could make points. Step 6 is make a table and make points, but I don't know that we need to because all it is this line. All right, we have this line that's going to look something like this. Okay, let's not make it dotted though. It's going to be a line that, well, we've got dots here and here and here and here and, okay. So the only thing is, don't forget the very first step. We don't just have x plus 2, we have a hole at x equals 3. So if you notice, at x equals 3, there's going to be a hole. So make sure you draw that hole there. And if you go back to the graph, it's really hard to see on a graphing calculator. You're not going to see the hole because actually it's infinitely small. And so if it was infinitely small, we wouldn't be able to see it, but we had to draw it with some size. So you're going to see it on your paper drawing, even though you wouldn't see it on a calculator drawing.